If I'm not talking loud enough, let me know.
Okay.
Yeah. And if you need to stop to take a drink of water, fine,
Oh,
no
okay.
problem, whatever.
Though Hanford wasn't involved, I once went to Vietnam to remove the highly enriched uranium fuel at a research reactor. But that was out of Idaho Falls.
Oh, okay. So it wasn't directly connected to your work at Hanford, but sort of?
Peripherally, some of the fuel came to the 300 area and was used in the trigger reactor here for work done on FFTF.
I think it'll be interesting to talk about that at some point during the interview.
All right,
All ready to go?
Yep.
Okay. Well, let's start by, first of all, just having you state your name.
I'm Wally Hendrickson.
Okay, great. And my name's Robert Bauman, and we are conducting this interview on the campus of Washington State University Tri-Cities. Today's date is July 30th, 2013. So I thought we could start by, first of all, just telling me how, when, why you arrived at Hanford.
It goes way back. My mother's cousin worked here from the early 40s on, and I knew about the reservation because of family visits. But I first came to work here in 1955. I was an engineering student at University of Idaho and got a summer job here with General Electric. That was a contractor at that time for the summer. And it really suited me. I've been very interested in science and technology all my life. In high school, I wrote a paper on disposal of radioactive waste. And I have 4 engineering degrees. I've really enjoyed technology. And I had the idea, idealistic young fellow, that engineers could do a lot of good for the community.
And so what was your you said you had like a summer job here when you were a college student? What sort of work did you
Yes,
do then?
it was for technical people, technical students, and it's to give the student a chance to get an early experience with a large technical organization. And of course, the managers here would look at the students and wonder if they would want to have them when the students graduate. And I worked here for 1 year in 1957-58, and I was a tech grad, which a few of the listeners may know. At that time, the technical graduate, like an engineer or physicist or mathematician, would be given 4 3-month assignments to work in different areas at the site. And I remember, I'll that later for that. I was really pleased at that opportunity. And I remember, one of the 4 3-month assignments I remember so well was water treatment. We treated Columbia River water for its use as cooling water in the breeder reactors or production reactors, I think they're called, that we had here to make plutonium for weapons. And we we cleaned more water than the city of Chicago. And our criterion was solid particles, not dissolved stuff, but little dust things that float around in the river and organic things. And I believe we sought to have the particles no more than 0.01 parts per million. And we had tricks that I think the rest of the world still hasn't caught on to. After the normal type treatment, is this dragging on too technical?
No, this is very interesting. Keep going.
Well, most municipal water treatments were much like ours, except ours was really jazzed up. And they'd put in a chemical that would form a flock. It looks like a tiny piece of cotton floating in the water. And when it forms, it readily picks up some dissolved material, but particularly particulate material, and that would settle when the water flowed through a very large swimming pool. Then the water would go to filters, and they were really fancy filters. I wonder if the rest of the world is caught up with that technology. And we'd add Separan, which was like lucite, a polyacrylamide, which is, it would give a particle in water with a number of valences. So it would attract particulates and enmesh them, and they would settle out or be filtered out. And I was able to work with two really great guys. One was a lawyer. He'd minored in chemistry in law school and graduated during the Depression when you couldn't buy a lawyer's job. So he taught chemistry in high school. And there was a law, whose name I don't know, that enabled the government to essentially draft people with skills critical to the war effort. And he first went to a munitions plant and then here. And I remember he set out to educate me. He told me about the first breach of promise suit in America. That was during colonial times, where a man died. His wife agreed to marry the neighbor and then thought that, oh, it's too soon. And he sued her for breach of promise and was given property from her. That's because in those days, it wasn't thought quite proper for women to have property in their name. So he actually lost something.
So what was this lawyer's name, this man's name?
I can't remember now. He was big, and I think he died in the 70s. And I talked to his wife when I came back here in the 80s, and she said he remembered me and would talk about me.
So that was one of the 4 areas you worked in during your...
No, that was a full-time employee, but I was a tech grad during that time and 3 months in water treatment. And, another very interesting assignment was looking at the water of the river, or rather, looking at the contamination that mostly the cooling water for the reactors would contribute to the Columbia River. And one bit of, I guess it's biological thing that amazed me. Phosphorus 32 would be made by fast neutrons on the aluminum cooling pipes in the reactor tubes, and it would produce phosphorus 32. Oh, I think I'm mixed up here. I'm not sure what the target was, but anyway, it would get into the water, and algae would pick it up. They're hungry for phosphorus, and the concentration of phosphorus on a weight basis of the algae was 300,000 times what it was in the natural, or just the water. And my colleagues would they would say, well, what does that mean? Does it affect health? And they found that whitefish would if they didn't eat the algae, they ate something that had eaten the algae, and it would get into their bones. Now, when you eat a whitefish, you usually don't eat the bones, but they didn't take that into consideration. And they knew that some people fished quite a bit out of the Columbia and fed their family the fish. So they calculated what this exposed people to. And if they fished all through the year and ate all of the fish and ate the bones, they would be getting close to limits for non-professional radiation workers. And I was really surprised when I heard about people saying the information regarding exposure of citizens was kept secret, because the very year I was here, 57, 58, the Public Health Service studied radioactivity in the Columbia River and wrote a report, and I had a copy of that report.
So was were levels of phosphorus sort of the main finding from the work you did in terms of the possible impact on?
Yes, though I believe some aquatic worm at the mouth of the Columbia would pick up cobalt-60, and they were hot. Of course, people don't eat the worms, and I don't know if the fish do or not. There was so much work to study what became of the radioactive materials in the effluent, and what kind of hazard that was. And I remember, I'm sort of a chemist too. I remember reading the reports of the radiochemists about the techniques they developed and applied to analysis of radioactivity in the water, either effluent or the river itself. There were people that got to go up and down in a motorboat catching fish for some of this. But much of the radioactive analysis had to come after quite a bit of chemical separation. A lot of things will get radioactive, and if you try to count a dry sample, it would be impossible to distinguish between those radioactive material, or nearly so. And they would use standard inorganic chemistry to separate different isotopes. And This place ran 24/7, and they liked to keep close track of the effluent, so they would build automatic systems to sample and automatically go through the chemical separations. If you've ever been in a hospital that has their own lab, you'll see big machines that are just amazing in being able to analyze for different organic chemicals in the blood. It's all automated, and nowadays it just comes out printed on a sheet. Sounds easy, but there was a time when it was very laborious.
Do you know if there were ever any changes made to any procedures in terms of the water after, with results about phosphorus and that sort of thing, or?
Well, changes. Now, I don't think there were many. They spent a lot of time finding out what was in the effluent and what it would do to people. And my recollection is that it was quite a ways away from any limit, any conservative limits that we operated from. I had heard, though, that the water treatment plant at Kennewick in those days filtered out radioactive particles, and that if one went over to the filter bed, I suppose this is after the water's gone down, with the Geiger counter, it was quite radioactive. That was in 1957. Yeah, let's see. Oh. Yeah, this is embarrassing. My bosses said, well, some reactors are better than others in reducing phosphorus 32 material. Why is that? Is it a function of the water treatment? So I was set out to set up one reactor. It had split water supply systems. So one reactor ran as normal, and the other reactor ran a little dirtier. I mean, other half of the reactor ran a little dirtier. And we ran it for quite a while. Stuff builds up on the tubes, fine particles. If you see something in a pond, you might, well, certainly you'll see algae growing on it, but you might see accumulated clay particles. And then we purged the reactor. We ran in diatomaceous earth, which is nearly pure silica from little diatoms, the bodies of little diatoms, and that would scour the fuel elements. And now this is done periodically to keep the amount down that we generated. And we took samples then during the purge, and they didn't make sense. And a couple of weeks before that, I'd gotten some records from an accountant who was stationed over at the coal-fired plant that generated steam. And I told him, I need to see these records, and this is why. And he says, well, but there is no correlation like you suggest. And I got the records, and yeah, there was no correlation. And my bosses had to admit that they didn't realize that, and I suppose they'd gotten some idea during a short period of time that wasn't typical.
So how long as a whole did you work at Hanford, and what other areas did you work in?
Well, after 57, I started a doctoral program in physical chemistry at Washington State University. It was a very difficult time for me. Let's see, we had gotten a raise as teaching assistants there, up to $200 a month. And I had a bachelor's and master's in chemical engineering, so I didn't have as much chemistry as the other graduate students. It was pretty hard. And I kind of washed out, partly for financial reasons, and took a full-time job at the research reactor in Pullman. Now it's called the Harold Dodgen Research Reactor. A radiation center is the name. He was a wonderful man, full professor of both chemistry and physics. Wonderful man, and so well trained. He was from Berkeley, as were some of the other faculty that I had. Well, I eventually got another master's in nuclear engineering and a PhD in engineering science. And then I came here for 6 months as a summer prof, they call them.
So what year would this have been?
That was in 71. July of 71. I came and unloaded my earthly possessions on a day that was 113 degrees. Oh, when I went to Pullman, I left the 13th of September, and the heat wave had not yet broken. And to that date, we had 100 days above 90 and 30 days above 100. And that was before anything like air conditioning in buses was thought of for the people that worked here. Yeah, I would be away from home 11 and a half hours a day. Be picked up by a shuttle bus that would deposit me at the big bus lot and then take a big bus out to wherever. And it was a toss-up whether it was we should have the windows open or have the windows closed, because the air was so hot.
And so what were you working on then?
Oh, the four tech grad assignments. And I spoken of two, water treatment and another looking at the radiation impact on the Columbia River. Then I worked with a group that, well, they called them material and processes. And when something had to be done, a lot of things fell in that category. And they would finish up the engineering if it were a new piece of equipment, and then see to procurement, or they would work on a better decontamination material. You know, when something gets into contaminated water, the contamination will absorb onto the surface and stay there. And to get it off, you have to do some pretty strong chemistry. And I've seen carloads of decontaminating reagents laying out in the sun, and I'd go test them. It's amazing what industry. Turco was a supplier of these decontaminating chemicals. And they would send us batches of new stuff that they'd worked up, and then we would test them here on with our contaminants, and would give the results to them. But they wouldn't tell us what was in the samples they had given us. And I thought that was kind of a dirty trick. And then I remember one fellow was working on epoxies, and I'd used epoxies at the research reactor in Pullman, so I knew something about that and thought it was interesting. Now there's a third one. I can't remember a fourth one, but I can't remember what it was. Well, after I finished the doctorate, I came here for 6 months, and then had 2.5-year postdoc at the Naval Ordnance Laboratory. Then I worked at Idaho Falls at the chemical reprocessing plant, and got run out of there and came to DOE at Hanford for 20 more years with FFT, 10 years with FFTF, and 10 years with the radioactive waste tanks, the waste coming from reprocessing fuel, reprocessing to recover the plutonium. And for a while they were recovering the uranium because we had huge quantities here that they wanted to use. They would put it back into service in another reactor. Oh, when I was here for 6 months as a summer prof, excuse me, that was really challenging. And when it was all over, I finally realized that what they'd done is given me the unsolved problems of 17 years of operation. And it was daunting. One thing I worked out with caveman techniques, no computer, nothing like that. But I had to know the chemistry used to separate cesium and strontium from the radioactive waste. And they were separated and put in a different place at high concentration. And they're not, then those long half-life isotopes, fission products, would not be in the humongous million-gallon tanks of waste. And they can use ion exchange resins to take out strontium. It's harder to do cesium, but they could do that too. And
what years would this have been that you were working on this stuff with the tanks and so forth?
Well, in '71, as a summer prof, I did 6 months, and then when I came back in '80, I came back to Hanford in '80, and I worked through the end of the century. The last 10 years, I worked on the tanks and the tank farms. Because of my technical interests, I would often get safety issues and the documentation that money is spent on in great quantities at facilities like this, environmental and safety documents. What was your question again?
Oh, my question is just about the time period.
Oh,
that
time
you were
period.
working on the
Yeah, it was in the '70s. And I had, at the postdoc at the Naval Ordnance Laboratory, I worked for a man that had been extracting and measuring cesium in natural waters. That means in a lake, a river, in the coastal waters, and up, I want to say Chamkaka. There's islands, a string of islands that go from western Alaska down almost to the Siberian coast. And a lot of bombs have been tested in the atmosphere, and the fission products go up. They absorb on bomb casing material and sand and whatever happens to be for it to absorb on. Then it falls into natural waters. And the government, through its various agencies, keeps a track, kept monitoring this. And my mentor at the Ordnance Lab had been following cesium. And, see, you know, the sodium, potassium, oh my goodness, what's next? I want to see it. It's been a long time since I had a chemistry course. They're very difficult to remove from anything. They don't readily form insoluble products. But there are a few compounds that can be precipitated from an aqueous solution to a salt that's insoluble that will take out some of these very soluble ions. And for cesium, cesium was a third one. Below sodium is lithium. If they mix a solution of nickel chloride, nickel sulfate, with a solution of sodium or potassium ferrocyanide, a precipitate will form. It'll be nickel ferrocyanide. And you know, it starts with a couple of these getting together, and then some more bump into them, and more till you get a real crystal. Well, when this goes on, the cesium is picked up just as if it were a sodium. Oh, that's not right. It gets into the crystal structure. It's a foreign body, but it is incorporated into the crystal structure. And it's really a good extractor. It sucks up the cesium to a very low concentration level. Well, then they can filter that out. And the cesium, as I said before, doesn't go to the big million-gallon tanks. Mm-hmm. And that was good. We like to keep track of our radioisotopes. Now these waste tanks, million-gallon waste tanks, everything goes in there. It's a dog's breakfast of processed chemicals and some things that shouldn't be in there. Now, as a kid, I knew about black gunpowder, potassium nitrate and sulfur and charcoal. And I knew how it would explode. Well, our tanks are chock full of nitrates, which give off oxygen for the burning of sulfur and charcoal. It's an explosive and a good one. Well, there you've got this oxidizing agent in huge quantities. And you've got nickel ferrocyanide intimately mixed with this oxidizer. And the cyanide radical is a carbon and a nitrogen. And carbon gives off a lot of energy when it's oxidized to CO2 or CO. So people would naturally wonder what might happen. And people study it, and people write papers on it, and senators say, "Oh my God, you find out what's going to happen." So they had a $25 million program to find out what happens in this mixture of an oxidizer and ferrocyanide. And they signed it to me. I had published in the area of cesium extractants and knew something about the chemistry. And before I got very far into it, I tried to find out what was known about it. And there are guys here they called the Graybeards. It was a senior process chemist. And they had thought it over and decided it's safe if it's wet. So that was in the back of my mind. And you may know about the, what is that? Committee? Nuclear Facility Safety Committee, I think. Really smart guys, cream of the crop, that really know their sciences. And they were set to looking at the government's nuclear facilities, and because there were a lot of noise, horrible things are going to happen or have happened, and government's covered it over, that sort of thing. Well, that became one of their concerns. So I've worked in civil service all of my life. I say I've never had an honest job. When problems come up and our government say that there is a problem and we got to fix it, then a bunch of people are gotten together as part of a bureaucracy, and they take care of it. A lot of times after that problem's gone, they still take care of things. But a very capable Westinghouse at this time man, and I can't remember his last name, Jim. He's a PhD physicist. He wrote up a program to thoroughly study this issue, and it was just what this National Committee wanted, that kind of approach. So we did 5 years of really good chemistry. And at the end, well, we proved that if it's kept wet, it's safe. But more importantly, we learned that the cyanide is decomposed. It's a rather energetic substance and readily reacts with other things, so it's not a cyanide anymore, and it's a soluble in water. It's not in the salt cake. Well, that was a fun time, and I quickly learned that, okay, what is needed to satisfy the committee is to do good science. And we may, by doing that, we may very well find a solution. And then the contractor and I had to close these issues. I think there were 4 or 5 reports we had to write to convince people that we have conscientiously studied and assessed the hazard and then state what remnant hazard there is and get their buy off, and then I could go do something else. So there's a lot of management or bureaucratic processes that bedevil the technical manager nowadays.
When you were during that time, when you were working with the tanks, were there any problems with leaking or any of that sort of thing at that point? Or?
Oh, that and other things. I'm kind of uncomfortable talking about some of that because there are people screaming, the sky is falling. And there's some real problems, all right. But throwing them into public conferences is kind of difficult, but it'll be handled with bureaucratic methods. And I, when people say, "Oh, things are terrible at Hanford," I say, not to worry. There are plenty of hardworking taxpayers. And I'm afraid they take it in the neck many times. But then, what is done out here in the cleanup is just amazing. I have always been concerned about radiation on health, and of course the bureaucratic approach, which worked very well. The health physics people here, Parker, an amazing man. What was done in radiation protection here at Hanford was first class. And I think very conscientious. I've heard about the very earliest limits of radiation exposure. At the time we started fissioning here, started the reactors operating, most of the data came from radiation therapy given to people usually for cancer, but other problems as well. And the radium dial painters, you do know what that is?
Yeah.
People would get watches and clocks with radium mixed with a phosphor, so it would glows all the time, but you can see it in the dark. And they would be painted in, and the ladies that did that had little artist paintbrushes, and they'd dip it in, and if they had to make a fine line, they would put it in their lips and rotate it, and died horribly from radium's chemistry is like calcium. It goes to the bone, and it's a bad way to go. But they started out from that level, and I think they were very rational and very conservative. We've since '44 we've learned a great deal, and we've lowered the limits.
You mentioned earlier that you spent a period of time working at FFTF.
Yes.
I wonder if you could talk about that a little bit at all, what sort of work you did there and your experiences in that work.
Bear in mind that in World War II there were a number of things that were very useful and high technology, and America developed them and used them, and they contributed significantly to the successful outcome, from our viewpoint anyway, of the Second World War. And of course radar is one, sonar. Lost my train of thought, just a minute. Of course, I think the power levels of our early primitive first built production reactors was up in several thousand megawatts of heat released. They were pretty big reactors, and people in the know said, that's a lot of power. Can we use it to power submarines that would not have to come up except for food and water and could be submerged for a month? Well, smart guys in the Navy and the Atomic Energy Commission made it happen. And very soon they had prototype power reactors online, making electricity, putting into the grid. And according to the cost estimates of the time, it would be very economical to produce power that way. And a lot of utilities got into that, and big companies like Westinghouse and Combustion Engineering, Babcock and Wilcox, and GE made power reactors and sold them. They were run in this country and largely were very successful. And so people says, well, let's look at the slope of this line. And by, I think it was the year 2000, we're going to have 1,000 big power reactors operating. And that's going to eat up the world's known supply of uranium. What will we do then? And of course, the physicists said, well, you can breed plutonium, and makes a fine fuel for power reactors, and they proved that. And FFTF was part of a big part of the technology developed. And because of this projection, they made decisions in the late 60s. I mean, projections of 1,000 power reactors being used in America in the year 2000. In the late 60s, the Atomic Energy Commission committed itself to developing breeder reactors and started a really smart program to get the kind of knowledge necessary to use that kind of reactor system. And For generations, the electric power generation in America had been increasing 7% a year, and people that we never give a thought to had seen to having that power available for us. And they put reactors in. They thought reactors were good and safe and economical. Well, FFTF was kind of the last of the great efforts along this line. And they were going to build a demonstration plant at, not Chalk River, that's Canada. Do you recall well, they were going to build a prototype, it means a big, nearly full-size reactor, and the lead time on some of this stuff, sometimes the lead time is 3 or 4 years just to get get billets to run through the rolling mills of a special alloy needed. So there were a lot of planning going on and ordering components, and the Arabs don't like our politics in the Middle East, and cut off delivery of oil. The price went way up. I'd heard that the cost of oil at a seaport in Saudi Arabia cost 25 cents a barrel because it's so easy to drill and it's easy to get out, and you can plan ahead on things like that. But our growth rate and growth rate of electrical demand went down, and I don't know where it stands now, but the whole world went through a technological crisis when that happened. And we had a kind of recession in this country, and a lot of the industry did not build in anticipation of growth. And they stopped building reactors. They finished the ones that were being built. And this projection of needing 1,000 reactors in 2000 was way off. I think we've had around 200 power reactors. I'm not sure, something like that. Well, we kept this program going in spite of economic changes and electrical demand, projected electrical demand changes. Though what we did here was wonderful science. The Japanese just shook their heads when we decided to shut down FFTF. In their country, they don't do things like that. They should have run FFTF until the wheels fell off, because we'll need that data sometime. And the materials development that took place at FFTF is just amazing. I have thought of NASA as doing wonderful things with science and big projects, cost billions. But I think what was done here in fuel and materials development is of that quality and that nature, and being a very big effort.
I was going to ask you, during your years working at Hanford, the different times you worked here, what you see as sort of your biggest rewards working here, and maybe your biggest challenges.
Well, certainly from my standpoint, a wild technologist, I appreciated that technical experience. There were great things done here. And it's easier, just off the top of the head, it's easier for me to say the benefits I got. And I got to work in very large, very, very focused management systems. And I saw quite a bit of development of the individual engineers. The contractors were good at that, at least when we had long-term missions. But well, of course, in the early days when plutonium was the product, I didn't have any qualms about that. I kind of trusted the government to be halfway humane if it were used in war. But at some point, I realized the system was crazy. The CIA in 1972 said that, I think it was 72, in a newspaper clipping I read, that we had more bombs at that time than we would ever use in a war. And we just kept producing until the environmentalists used the environmental regulations to shut down the production facilities. They were dead right about, CIA was dead right about having all we needed. And bureaucracies, once they get started, are self-fulfilling.
You just mentioned sort of the shift from production to cleanup. Obviously, the mission changed, and you were here during both phases, I guess. I wonder if you talk about how that shift impacted your work at all, or changes that you saw as a result of that sort of mission change in mission.
Well, the turnaround of the mission occurred before I got here in '80. It was thought, when I got here, we were deep into cleanup. When I worked as a summer prof in '71, I talked to old-timers, and they told me this one tank level goes up and goes down, and up and down on a rather regular basis. And they didn't know why. I had no idea why. And now we know very well. I think we spent around $100 million getting that knowledge. And it was touted as a great incipient disaster. We're going to blow those tanks up and blow that waste all over. So it was known, and it wasn't worried about at one point. People do get complacent, I guess. But then again, they sited these facilities out in this unpopulated desert. Some people from the east, when they came out here, they come to the airport and get in town, and and then they have to drive 55 miles out to the facility. Most of the world doesn't think that way. So we built in great depth of protection in simply where we sited it. One thing that they did, they released huge quantities, industrial quantities of carbon tetrafluoride, carbon tetrachloride, that was used in extraction and cleanup of plutonium. And they released it to the ground. I think there were thousands of gallons. And that's not smart to do that sort of thing. We released radioactive streams to the ground that were very, very, very low in radioactivity. And I don't worry about that sort of thing. It's not going to lead to any harm, in Wally's opinion. But some some things that they found out there are really amazing. These old timers that worked around the tank farms said they would throw radioactive tools, dirty, contaminated tools down into the tanks, and they would throw radioactive machines that they didn't want anymore down in the tanks. This is just hearsay. And the tanks whose level would rise and low were studied, like I think it was around $100 million. They found out that there are radiolytic gases given off, and gases given off by chemical reactions, even after decades in the tank, still going on. Well, some of the gas attaches itself to particles, so it doesn't bubble to the top. And that heavy sediment at the bottom gets lighter and lighter and lighter, and then it rises up and goes to the surface, and the gas bubbles expand and they break, and you've got explosive gases in the tank. Well, guys told me that some of the fellows would light a match and drop it down the tanks, and light a piece of paper and let it float down into the tanks and go woof. That's not first-hand information. But people sure can get worked up about things.
Security and secrecy were sort of always connected with Hanford. I wonder if you could talk about that at all in terms of maybe the first time you were here in the 1950s. Do you have a special clearance at all? And did secrecy sort of change at all from the time you were here in the 50s into when you were here later in the 80s?
That's a subject I have strong feelings about. I think they did a very good job, and I trust their judgment that it was necessary. Yeah, it was part and parcel of living in Richland. I was told at one time you had to have a clearance, security clearance, to live in the town of Richland. And I think there are a lot of the old timers here. And I believe Richland has a very low crime rate. Carry over from those times, I think. People that they wouldn't give a security clearance to live someplace else. They didn't come here. Of course, I was young and what's the word? Impressionable. And I saw all the guards and had a badge and flash it. And it got so when I go to a grocery store, I'd take my badge out. Nuclear weapons kill people by the hundreds of thousands or millions for the big hydrogen bombs. And we wouldn't want the technology or bomb material or the bomb itself in hands of people that we don't want to have it. And when you think of the consequences of failure in the security area, you realize why they are so thorough. Now the rules are thought out carefully by experienced people, and the rules are pretty well written out, and people are able to follow those rules. So I think we owe a lot to the safeguards and security programs that have been part of this world.
I'm wondering if you could talk about overall your thoughts on Hanford as a place to work.
I was surprised when I came as an undergraduate at how happy the people were with the Tri-Cities. They liked it. And I'd come from mountainous, timbered land, and being out here, this sandbox was something different. I think people like it here. As a technical guy, I was glad I was in this environment. I think the Richland Police Department is a couple of notches above the average. I think that's a carryover from the effort made in this area by the Manhattan Project. One bad thing about Hanford is it would have economic ups and downs, really severe ones. And a number of times in my experience here, I've seen weeds growing and cracks in the sidewalks and closed businesses. It looks like we'll have a good economy here. This handling the cleanup is going to take decades, and I think they even haven't planned too much for the very end.
Before we started recording, we were talking earlier, you mentioned something you had worked on during the Vietnam War. I know it's not directly related to Hanford, but I wonder if you might want to talk about that a little bit.
Well, there was a connection with Hanford. After I left that postdoc at the Naval Ordnance Lab, I worked at Idaho Falls with Atomic Energy Commission, in a group that looked after the fuel reprocessing plant, and we would call it the chemical plant. And after I'd been there about a year, a message came from headquarters that they wanted volunteers to go to Vietnam to take out the highly enriched uranium that fueled a Trigger-type reactor at Dalat in South Vietnam. And they wanted people with health physics and trigger reactor experience. Now, I'd worked on a trigger reactor for 10 years, and a kind of a lightweight health physicist. And my buddy was a GS-14 health physicist at Idaho Falls, and he had been president of the western section of the Health Physics Society. So he and I talked and said, yeah, we'll volunteer. And we were the only volunteers out of about 20,000 AEC people. When I worked at the radiation center in Pullman, I chummed around with a lot of the graduate students and postdocs. I really enjoyed that. And one developed into a friendship. He was a Vietnamese physicist trained at the University of Saigon. And some of their degrees are taken as the same level as the Sorbonne degrees in France at that time. And he worked on a nuclear engineering master's program, and he was earmarked to return to work at the reactor that was being built. And so it was quite a complex. They even had their independent power diesel electric generator. Well, he wanted to stay for a doctorate in radiochemistry and started on that, but his country demanded he come back. And he worked at the reactor, and he and I corresponded. And he told me about meeting a small pharmacine. I guess that's that's the feminine form of pharmacist in French. And I'd hear about his courtship and had a baby. And then he didn't answer my letters. And when I was in the D.C. area at the Naval Ordnance Lab, I called the Vietnam embassy, and the man I got had been my friend's boss at the reactor. And T was dead, Levant T. And I'd learned about his experience. He and his wife and little girl, Christine, had gone up to Hue, where T's father lived, for the Chinese New Year. That's a real big thing in Asia. Well, of course, that was in the time of the Tet Offensive, and the Hue was overrun, including the Citadel, and American and Vietnamese forces eventually pushed them back. T had been seen by some of the Viet Cong, and one fellow knew him and fingered him, and he was taken as prisoner to a park and kept there. And after the Viet Cong realized they'd better retreat, the prisoners were taken out to the edge of the city and put in a ditch and shot. which isn't as bad as it might be, because sometimes they would douse them with gasoline and light it. Well, I knew about the reactor in Dalat from my association with tea. And John Horan and I, John died probably 20 years ago. He was an airman in the Second World War. We said, yeah, we'll go, and that was sent back to Washington. That was Friday, and I went with a scout group up in the hills outside of Idaho Falls, and I'd made 2 toboggan-like things out of old skis with a seat on it, and the boys played with that. And I went hiking. I came across a pregnant doe, and I followed the tracks. I heard the noise, and I realized eventually that it was pregnant doe, so I broke off. But I was doing that on the weekend, and Monday I took flight for Vietnam. And I didn't have a passport, so we made arrangements for special treatment with the passport office in San Francisco. And it was a hassle. The guy that was supposed to take care of that detail had gone to a dentist and not told anyone. When Iran got back, he wrote a bad letter to that guy's boss. But we got it. We finally got it. And got a visa from the Vietnamese and flew over. That's a long flight. And we were met at the airport by the first secretary, political military. He was a career Department of State man. I think he's still alive. He's in his mid-90s. Just a first-class person. Well, the first thing he did when he recognized us was remind us that we were volunteers. Went downhill from there. We were to go up in a small plane to reconnoiter, see what conditions were at the reactor. And let's see, that must have been a 4-seater. There were 4 of us that went up. Jay Blowers was his name. Let's see, what was it? Air America, run by the CIA. And I couldn't see the compass I sat in the back, and but I could tell the direction by the sun. Instead of flying from Saigon northeast to Dalat, we went directly east, out over the South China Sea, and then northeast, and then directly west. And when I'd figured that out, I said, why? And they said, well, the Viet Cong has very respectable anti-aircraft capability between those 2 cities. I thought, okay. And but when we got there, I think it's at 5,000 plus feet, and it's a wonderful place after you've been down at sea level in the tropics. And the French developed it as a vacation area, and there was a college there, and a school for non-commissioned officers, and I saw all kinds of agriculture. Oh yeah, there was an agricultural school of some kind. Well, we came to an area that was nothing but clouds. and there were peaks, mountain peaks around. And we went round and round and round, trying to find a hole. And we were just about to the point where we would have to leave because we only had enough gas to make it back to Saigon. And the pilot saw a hole, and he went like that, and leveled, and we were going straight towards a mountain. He went like that, and there was a landing field, and plopped down on the field. It was so fast. I didn't get to react. I wasn't used to that kind of flying. Well, we found the reactor in very good condition, and they had a fork truck which wasn't in good condition, and we needed a fork truck to lift shipping containers. The ones we got were brought by air from Bethesda Naval Hospital in D.C., and they were 55-gallon drums, and they had a pipe, an ordinary plumber's type pipe. It was kind of big, though. It must have been 6 inches. And there was some lead around it, and then concrete around that. And they were pretty heavy, so we needed heavy handling equipment. And they had a bridge crane. Now, a lot of research reactors are built like this one, which is in a round building, straight walls, and then a dome. And there's a ridge up at the top that a crane, polar crane, I think they call them, goes like this. And they had some problem with it, but they said it would work. And the water was in excellent condition, though they had shut it down since '68. The head of the reactor, the manager, became a close friend, and he has died. This was in '75, March of '75. This is interesting. Wally did something smart. Two things smart. When we were in Saigon, we quickly went over to the Vietnamese Atomic Energy office and said, we're from the government and we're here to help you. And we'd gotten sign off by the political type that was over such things as research. And we said, we want your help. We want to go up and see what's there and what we need to get the fuel out. And how hot is the fuel? Stuff like that. And of course, they didn't know because they hadn't fooled with it for 7 years. And that they had shut it down. And I thought, whenever in the nuclear field they do something like that, they write a safety report. So I asked, do you have a safety report? May I see it? And in the report there was, typically they do the thought experiment of, well, what happens if the fission products are dispersed in the air, the whole bunch? And so I saw that they had figured out the amount of cesium and strontium. Those are the long half-lived elements. They wouldn't have gone down but a little bit in 7 years. They had that all worked out. And I says, well, from that amount of so many curies at this distance, you'd get this dose rate, but we'll only take out one fuel element time. Piece of cake. It's no problem. But anyway, we took out a fuel element because we wanted to survey it. And Haran had bought our emergency response box. We had dosimeters and radiation instruments. Some of them we got from Berkeley. I don't know how that was arranged. And we would take the fuel out with a long hose that had a gripper at the end. The trigger had a little post sticking up that was sort of arrow shaped, and a neck, and mechanical thing on this garden hose went on that post and clamped onto the neck, and we'd pull it to the surface, and that particular hose system had a history of dropping the fuel elements, so we immediately grabbed the fuel element in the bare hand and disconnected it. And a guy over there about 8 feet would read it with a GM tube. That's what this case was. And well, the guy with the survey instrument was down on the steps a ways, and he walked up, which also brings him closer, and we could hear the count rate, and it stops. And that people experienced with high sources and GM tubes know that it's saturated, and it's really hot, and you better get away. And Haran says, "Oh, we got a divide by 10 thing. We'll put that on it." Well, the thing that goes bad in counting the radioactivity is in the Geiger tube itself. So the divide by 10 was useless. And we got, and I said, well, let's just stand back farther. And we got a good reading, valid reading. That tickled me that the Idaho health physicists hadn't picked up on the instrumentation they had for emergency. Well, let's see. Oh, I guess this might have been the second trip up there. But anyway, there was a little fence around the grounds and a guard's house at the entrance and a lean-to made of bamboo on the side, and a family was living under that lean-to. And they had several children. One was real small. And I talked to them, and they didn't know English, but I talked to them anyway. And the little girl had, I don't know if they call it hair lip, but anyway, her 2 front teeth were growing on bone, jawbone, that was in front of her lip. And you know, wars are expensive, and a lot of things are neglected because of that. And I really hate to see war any place. Problems like that can be dealt with so easily. But I had some time, and I offered to give the children a tour through the reactor. I guess the guard spoke enough English, so I took them and pointed to the crane and pointed to this great, oh dear, the reactor was in a silo-like concrete shield with water. And then we climbed a step up to the top. But anyway, I pointed to different things, and then I took them into the chem labs, and there was a model of the reactor. And I had this, oh, see that reactor out here? Here's a model. And the oldest girl, you could just see her face light up. She understood, and she explained to the kids what it was. Well, then we went back to Saigon and communicated with headquarters. Atomic Energy Commission headquarters. I found out that this was handled at a very high level. It was, the White House decided who was going to pay for the recovery. And an Air Force general was given responsibility for transportation. And an AEC fellow, of course, handled the AEC part. And I met him.
And then the connection to Hanford was?
Well, oh yeah. Do you have time? I can tell more about actually moving the fuel.
Just a little more, yeah.
Well, we got the fuel out. The C-130 was overloaded and we didn't know it. And the airport runway was on top of a hill, and we had to fight off people that wanted to take refuge in our plane and be taken out to the south. And the plane was backed up, and the engine revved up as high as it'll go with the brakes on, and then the brakes are released. And it starts out about like a baby buggy, just rumbling along, and the engines are straining. And it did pick up speed, but at this time I could see out the pilot's window, and we didn't so much take off as we ran out of runway, and there were farmhouses on outside the wings, and we got back, and then these heavy casks were loaded on a different kind of airplane, C-141, and taken to Johnson Island, and then to the States. And some of the elements came here to Hanford and was used in the FFTF complex for experimental work. And I met the director of that reactor. So he was a good man.
Yeah, that's quite a story. Are there any, you need to wrap up here, anything I haven't asked you about, or any things that you think is important to talk about that we haven't talked about yet?
Anything else I think might be important?
That I haven't asked you about, or that we haven't talked about yet, that you'd like to say sort of briefly here at the end?
There are a number of things. I could think a little bit. Maybe I'll make some notes and contact you.
Yeah, we could always schedule another.
If it seems worthy, I'll contact you.
Okay. Well, I want to thank you a lot for coming in today. Really appreciate it.
Yeah.
For sharing your memories and your experiences. All right.